All right, guys, we got sum and difference formulas. These are in the very bottom section of your blue sheet. You're also going to need a unit circle as you're doing this. And a couple of things I just want to call attention to. These formulas are really helpful when we want to find the exact value of an angle that is not on the unit circle. Like for example, 75. 75 is not on the unit circle. And now certainly I could plug into my calculator sine of 75 degrees, and the calculator will give me something back in return. And of course, that's an answer. That's not the exact answer. So what we can do is we can split 75. You're looking for, when you're doing these problems, you're looking for angles that are on the unit circle and that can be combined, whether it's addition or subtraction, to get the angle in question. A couple things I want to note about the formulas themselves. Sine of and it's alpha and beta, and I think it's U and V on your worksheet, but really or your blue sheet, but really it just means first angle and second angle, okay? So it means first angle and second angle. And notice how the addition, like it's addition plus minus and plus minus here, it's not like the quadratic formula where you're going to find two answers where, oh, it's positive and negative. No, it's just a shorthand way of writing these equations. So if we're doing the sine of alpha plus beta, so sine of the first plus the second, we've got a plus in the middle of those two things. If we're doing minus and we have a minus, it is flip-flopped for cosine. Notice how if it's first plus second as far as cosine, then we subtract there. If it's minus, then we are adding. So it's flip-flopped. And I think I put that on your PDF file so that you know it's there. Okay, and tangent then, it matches in the numerator, it's opposite in the denominator. So let's do a couple of examples. All right, we want to find the exact value by using a sum or difference identity. The very first thing that you're going to do is actually simplify that within your parentheses. The reason you're going to do that is because sometimes we actually have these things and they are on the unit circle. If I do 215 minus 95, it is 120 degrees. So I can actually just take the sine of 120 degrees. I don't need to do anything with the sum or difference identity. We can use this. It is on the unit circle. So just go to the unit circle and grab the y coordinate. So that value is radical 3 over 2. Okay? Sine of 255, if you look at 255, you're looking, and it's not on the unit circle, right? It's not on the unit circle at all. So you need to find, there's a train going on. You need to find the combination of angles that are on the unit circle that would work. So 255 is the same thing as 225 plus 30. It's also the same thing as a 120 plus a 135, right? There's just several combinations that you can use. I'm going to stick with the 225 and the 30. So instead of writing the sine of 255, I'm going to write it as the sine of 225 plus 30. So the sine of 225 plus 30, and that's really what you're going to do now. You're going to look at your Pythagorean identity, or not your Pythagorean identities, I'm sorry, your identities on your blue sheet, and you're going to figure out how you're really going to split this up. We're going to expand it. So we're going to do the sine of the first times the cosine of the second plus the cosine of the first, times the sine of the second, okay? That is literally me just pulling that off of the blue sheet. Sine of u plus v is sine of u, sine of u cosine of v plus cosine of u sine of v. And it's just easier to say first and second. All right, so go to your unit circle. The sine of 225 is a negative radical 2 over 2, right? Times the cosine of 30 is a radical 3 over 2, plus the cosine of 225, so I went back and got the 225 again, is a negative radical 2 over 2, times the sine of 30, I'm going back to the sine, and the y value there is 1/2. Okay? When you are multiplying your fractions, you are multiplying across the top and across the bottom, so this is a negative radical 6 over 4, plus a negative radical 2 over 4, which then means I can write it as negative radical 6 minus radical 2 over 4. Now, Your book your book and the software and everything like that, they like to actually factor out a radical 2. Just leave it like that. All right, next. Cosine of 45 plus 60. Here's the thing. This is already split for you. So it might have originally been written as the cosine of 105, right? And cosine of 105. 105 is not on your unit circle, so you can't really use the unit circle at that point. So what we're doing is we are going to expand this. Now, a couple things to note. This is a plus, so when we write it, when we're expanding it, we are going to write it as a minus, and you've got a first angle and a second angle, so 45 and 60. So here's how we write it. And again, I am just pulling this off of my blue sheet. So the cosine of u plus v, or the cosine of the first plus the second angle, is cosine of the first angle times cosine of the second angle minus, it's the opposite sign, right? Then you've got sine of the first times sine of the second. Okay? So cosine of 45 is a radical 2 over 2. Cosine of 60 is a 1/2 minus sine of 45 is also a radical 2 over 2. And the sine of 60 is a radical 3 over 2. So I'm multiplying those, and again, oh, that should have been blue, but that's all right. I'm multiplying these again, so I've got radical 2 over 4 minus radical 6 over 4. Write it as a radical 2 minus radical 6 over a 4. And again, your book would actually factor out the radical 2 right there, and when you do, I'll just show you real quick so you see it. It is a radical 2 times a 1 minus radical 3 over 4. There's really no point in doing that. I don't understand why your book always does it. Okay, so that's 3 of them. Let's get to the tangent one. All right, we got tangent of the first tangent. Oh, wait, sorry. I just added a new sheet. That doesn't work. All right, there it is. Tangent of 255. 255 is not on the unit circle. All right, I'm going to happen to use 225 and 30. You may use a different set of numbers, and that's okay, but you're going to split it up. Tangent of 225 plus 30. Okay? All right, so here's what you're doing. You are going to take the tangent of the first, not 3, 225, plus the tangent of the second over 1 minus the tangent of the first times the tangent of the second. Okay? Ooh, that's getting terrible. All right. Tangent is a little bit rougher to work with just because you're going to end up having a bunch of stuff. All right. The very first thing that we're going to do, tangent of 225, and I'm not going to show you on the video because I do show you in your PDF file. 225, the coordinates there are negative radical 2 over 2 and negative radical 2 over 2. Oh, that might be a goofball. I think I forgot my negatives in the other one. Hopefully I didn't. Maybe I didn't. I think I may have. Guys, if I forgot when I did sine of 255, if I forgot my negative signs, please forgive me and go back and add them in. All right, so tangent of 225, negative radical 2 over radical 2. I'm sorry, negative radical 2 over 2 and negative radical. Basically, your x and your y are the same. When your x and the y are the same, when you put y over x, you get a 1. There you go. Plus, when you do the tangent of 30, it's going to be the y value, which is 1/2, over the x value, which is radical 3 over 2. Okay? And then you're going to have 1 minus, and again, the tangent of 225 is just going to be a positive 1 times a 1/2 over radical 3 over 2. Ooh, that's a terrible radical 3 over 2. Okay, so I'm going to strengthen this up a little bit. All right, at this point, we're going to do, here's the thing. I don't want to go into too much detail here because this is stuff that, we should have been doing or have been doing in the past. So 1/2 times 2 over radical 3, right? Guys, you have to, I don't think I rationalized in the notes, This is going to be a 1 over radical 3, right? Which when we rationalize it is a radical 3 over a 3. So my numerator is going to be a 1 plus radical 3 over 3, and my denominator is going to be a 1 minus radical 3 over 3, because I am dividing by a fraction, I multiplied by the reciprocal, and then I had to rationalize that denominator. I'm going to allow you to stay right there. You can leave it there as an answer. In fact, I think I did on the notes. But really what ends up happening is the 1's become 3's over 3's, so the numerator looks like this, right? 3 plus radical 3 over 3, and the denominator looks like this, 3 minus radical 3 over 3. Then you would, you would take your numerator, 3 plus radical 3 over 3, times the reciprocal of your denominator, so 3 over 3 minus radical 3. The 3's here are going to cancel out, so you actually have a 3 plus radical 3 over a 3 minus radical 3. And then again, oh good grief, you would actually multiply by the conjugate to rationalize that denominator, but I'm not going to get into that because, again, I told you could stop here. Told you tangent was bad. All right. So now, number 5 basically takes the right side of your sum and difference, it's the expanded side, and you have to reduce it down to your simple side. So here's the thing. We're starting with a sign, so it's obviously one of the sign formulas. This is a minus here, and remember, the plus and minus need to match for the sign. So this is really going to be sine of, it can be alpha minus beta, or u minus v if we're putting it in terms of our blue sheet. And so we're really just going to do the sine of 245 minus 50. So we're really just doing the sine of 240. Guys, go to 240, grab your y value, and you get a negative radical 3 over 2. Here's the hint on this. If you did 245 plus 5, you get 250. 250 is not on the unit circle. Obviously, that one's not going to work. Okay, next one. All right, this is obviously a tangent one. You don't even have to worry about it, but it is tangent. And so what you're going to do is you're actually going to look, because it's tangent, we know it's tangent, we're going to look and see that this is a plus on top. Tangent in the numerator matches the sign, so we're going to do a 25 plus 5. So we really just want the tangent of 30, which is a 1/2 over a radical 3 over 2, which is 1/2 times a 2 over a radical 3. Those 2's are going to go away, so we have 1 over radical 3, and when we rationalize that denominator, we get a radical 3 over 3. Okay? This way, tangent is much easier and faster. It's when you have to do the expansion that's a little bit rough. And again, same hint. If you were to do 25 minus 5 instead of 25 plus 5, you would get 20. 20 is not on your unit circle. Okay, last one. Use the given information to find the exact value of the expression. Sine is 7 over 25, and it lies in quadrant 1. So we got two angles. We got alpha and we got beta. So sine, the alpha, right, is in quadrant 1, and sine is 7 over 25. Remember, you're sitting at the origin. Sine is opposite over adjacent, right? You would use the Pythagorean theorem. I'm not going to walk you through that, but you would use your Pythagorean theorem to find that 24. And then you're actually going to draw a second picture for beta. You can put beta on the same picture, but honestly, it's easier to draw a separate one. Beta lies in quadrant 1 as well, so it's over here. Everything's positive in quadrant 1. There's our angle. Cosine is adjacent over hypotenuse, so 8 over 17. And again, Pythagorean theorem to get this 15. I'm not doing that for you. We want to find the cosine of alpha plus beta. So cosine of alpha plus beta equals the cosine of alpha times the cosine of beta. So cosine of the first times the cosine of the second minus, remember those signs are opposite. This was a plus, this is a minus. And then we have sine of the first, or alpha, times sine of the second, or beta. So really, all you're going to do is use your circles, or not your circles, your diagrams, sorry, the triangles is what I meant to say. We want the cosine of alpha. So we go over to our alpha drawing. Cosine is adjacent over hypotenuse, so that is going to be a 24 over 25. Times cosine of beta, well, we actually already had that, but we can also see on our circle that it's 8 over, again, triangle, not circle, that it's 8 over 17. Then we're going to do sine of alpha, and so we're back to our alpha picture, and we were given that the sine is 7 over 25, so that's 7 over 25, times sine of beta. So I'm going to go over to my beta drawing, and I want the sine, which is opposite over hypotenuse, so 15 over 17. There is no reason on this earth for you guys to not get this right. Go to your calculators. You can plug everything in as one, and then just hit math, enter, enter. If you do the first part, this will give you a 192 over 425, minus your second part will give you a 105 minus 425. And so your actual answer, the cosine of alpha plus beta, is 87 over 425. And again, if you went and just entered everything in your calculator all at once, you'd be set.